People make games using a game engine such as Unity, Unreal, or Godot. Some go lower level than that, using a library instead, such as Raylib, SFML, or Pygame. But sometimes you get the itch to go even further, to go and make almost everything yourself. And recently, I've gotten that itch, so I'm making a 2D library. A small group of people will also go all the way down to make everything from scratch, including the window, but I am not that crazy, so I also prefer using C# rather than lower level languages like Rust, C, or C++. So because of this, I'm going to use silk.net, which does use C++ libraries, but it is all exposed to C#. It also uses, well, it has OpenGL bindings, which just happens to be what I want to use for my graphics backend, and it also has DirectX 11 and 12 bindings, Vulkan and Metal bindings too, so if I ever want to add those backends to my project, I can. To get started, I need a window, so we're gonna add silk.net's windowing and maths namespaces to our file, and then we're also going to add the OpenGL input ones for later. So to make a window, I need a window option struct, and I'm going to set the size to 800 and 600, and then set the title to be Lumen2D. And then we add an iWindow member to the, or field to the class, and then we set it to be window.createWindow, passing in our window options that we just made. And now when we run the project, we get a blank window on the screen, which is pretty nice. Next, we'll add the onload, update, and render methods to our class, and then we add these to each of the window's respective events. And then we'll add an input context field and then enumerate through each keyboard connected to the computer with an event handler for when a key is down. We will then simply check if that key is escape, and if it is, then we close the window. And then we need to set the input context by getting it via the window so we don't crash, like what just happened here. And then now when you open the window, when you press escape, the window closes, which is amazing. And then I also changed the class to be called GameWindow and made these methods virtual protected ones so that you can override them. to have different functionality. Now we get to the main part of the video, and that is rendering. This is a 2D rendering library after all. So to start, we need to add a GL field to our window class, and this holds the OpenGL context we will use for all of our OpenGL calls. And then we're going to create the OpenGL context from our window, and then in onload we set the clear color to be cornflower blue, and in render we clear the color buffer bit. And actually, instead of setting it after we create the window, we want to do it on load so the window is initialized. And you can create a context. And now when we start the program, we get a blue screen instead of a black screen. This isn't that exciting though, so we're going to add a VAO, and VBO uint fields to the class, which uint is an unsigned integer. We also add an IBO unsigned integer, which we won't use right now, but we will use it later. So these are going to hold our vertex layout, our vertex data, and our indices, which I'm not going to go into much detail about how these work, but I will link a Learn OpenGL page in the description in case you want to read about them. It'll also describe shaders and textures and whatnot. Anyway, so to create our VAO and our VBO, we will set it to create vertex array and create buffer respectively. And then we're going to bind our VAO. And then our vertices need data. For now, just positional data, so we're going to create a float array, and then we're going to have 6 floats, which we're going to have an X and Y for each vertices, so that's 6, because 2 per vertex. And to set our vertex data, we first need to bind our VBO, and then we set our VBO's data to our floats. And now for our VAO, we just need 1 vertex attribute for now, and that's going to be 2 floats with a stride of the size of 2 floats. Which, if you don't want to do this, it is 8, because each float consists of 4 bytes. And now, to draw this triangle, we need to add gl.drawArrays segment in our render method. But before we can start our program and see our triangle, we need to create a shader. So we put use shader just above the draw call, and then we're going to create the shader. So you can choose to put these in a file, but I put them in the class directly, so we don't have to worry about I/O, especially because I don't want people to worry about needing to make sure that my files are in their projects. So we create a fragment and a vertex shader, and what these do is the vertex shader sets the GL position, and then the fragment shader sets the color to yellow. And now in onload, we need to create a new unsigned integer called vert shader, which we're going to set to a new shader, and then we're going to set the source to be vertex shader. We then compile the shader. And then we do the same thing with fragment shader, but we're going to go back to the vertex shader and check if it compiles correctly, and if it did not, then we throw an exception saying it failed to compile with the message, and then we do the same for the fragment shader. And then we can create our actual shader, which in OpenGL is called a program. We attach our shaders to it, and then we link it. And then we check if our shader linked correctly, and if it did not, we throw, and again we send a message to the console or in the exception message. And now we detach and then delete our shader modules. And now when you start the program, we get a triangle on the screen, but sprites are drawn in quads and not triangles. So to get a quad, we add one more vertex to our vertices array. And then we're going to start using our index buffer. So we're going to have a uint array. It is going to have 0, 1, 2, 2, 3, 0, and this is just our indexes into our vertice, to our vertex buffer for each vertice. And this allows us to not have duplicate vertices. And then we create our IBO with gen buffer, and then we're going to bind our IBO, and then we're going to set our IBO to our index data, which we're going to use element array buffer instead of array buffer. And now we're going to use draw elements instead of draw arrays in our render method. This one's a little different because it still has the primitive type as the first parameter, but instead of having the start index and then the end index, next we have the number of indices we want to draw, the index type, and then we have a pointer to where we're going to start the index array or our indices from. Which for some reason we have to cast 0 to a void pointer instead of passing in int pointer dot 0, which I think I could have probably passed in null as well. I think C# automatically converts that to be a void pointer in a unsafe context. It's fine, because when we start the program, we get a quad. There is one last thing I need to do before I can start abstracting everything and make this bright rendering system, and that's textures. Textures are actually very easy to add. First, we need to add UVs to our vertices, which also means we need to add another vertex attribute for our UVs. And then we change our shaders to use the UVs. So we pass the UV vertex data to the fragment shader, and then to make sure that our data is getting sent correctly, we're going to set the color to be our UV data. And you might notice that when I start the program now, the UV is flipped, and that's because in OpenGL, sampling starts at the top left corner instead of the bottom left corner, which means you need to flip it on the y-axis, which I do flip the UV data and the vertex data so that it is the same as it would be anywhere else, which is okay for now, but we will need to fix that when we're sampling our texture. And as important as UV is, we can't sample a texture without a texture. So to get a texture into OpenGL, we're going to add SDB image sharp, which is a C# binding of the great SDB image library for C or C++. Then we're going to use SDB image sharp to load a tree image I found off of Google. And after we load the image, we will use the result to set the texture data. And then after this, we need to set the texture sampler parameters, which we tell it to wrap on both, or repeat on both axes if our UVs fall out of the range of 0 to 1. And then we're going to use nearest interpolation for both upscaling and downscaling the image. And we do not use the MIP versions of these interpolation settings or the filter, because if we do that, we need to generate MIP maps, and when we do, we have more texture data, and MIP maps are useless in a 2D program because there's no depth, so there's no point to use it. Now we'll add a sample uniform to our fragment shader, and then in our code, in our onLoad method, after a shader has been bound, we're going to set the sample uniform to be 0, which tells OpenGL to use texture unit 0, which is what we're binding our texture to. And now when we run our program, we should get a texture on the screen. You'll see that the texture is upside down, and this is because I flipped the vertex data in the or the UV data in the UVs in the vertex data, so we need to flip it in the vertex shader or the fragment shader. Okay, so I'm gonna switch to open commentary from now on, just because it's going to be easier for me to explain what I'm doing as I'm doing it. So since the last clip, I have pretty much just abstracted a bunch of things. So I've abstracted shaders, textures, and then I've also hidden OpenGL directly, so you cannot touch it anymore. We have an index buffer, vertex array, and vertex buffer, which are all internal, so that, again, the end user cannot touch these because they should be using a sprite batcher, which I will be making in the future. So these just take in a little bit of data, and then we set the buffer data. It's pretty simple. You can also tell it if it's going to be dynamic or not, which is always going to be dynamic in case, but there in case I need it. And it's really simple to add. Yeah, so our graphics device literally just is exposing OpenGL to the user, and the only thing they really need from OpenGL at this current moment is clear color and clear screen. So, you know, I just added these two and then that's it. If we go to our game window here, I added a set icon method, and it's just that's the window icon since window is internal. And then I also added a window info so they don't have to work with, well, so that they cannot mess with the window options. And only what we say they can, so the size and the title. Then we add our load, update, render, and then our resize event handlers. So we have our load method here, which we then call onLoad. So this is the stuff that the user will be able to set themselves, and then this is the stuff that must always happen. Then we have our key down as before. Reset up here. Yeah, but we have, you can see here now, instead of having the OpenGL calls, I can just call vertex array bind. I don't think I need to bind the index buffer anymore. We can use our shader, we can bind our texture, and then we can draw elements, which I will move this to somewhere else. So we can get rid of unsafe. Well, technically I do just an unsafe block like this. Boom, unsafe gone. But yeah, so I also added matrices here, so we can see we have projection matrix and a view matrix, which these do work, but if we open our window, you might notice something, and that's our square right there. I'm not sure if you can even see it, but it's one little pixel on the screen. Because our object is literally 1 in size. So if we make this much bigger, so how I can do that is by taking all of the 0 points and replacing them with nothing. Like that. Now it should be bigger. 10 times bigger. Okay, well that's not right, but because that should be negative. But you can see here it's bigger, and if I make it even bigger to 50, there we go. So we have our tree back, and if I okay, well that is not correct, but that's the wrong way around. Usually when you resize the window, it doesn't squash and stretch. Okay, I don't know why this is happening. We can ignore it for now, I'm sure. I'll fix it later. So the first thing I'm going to do now is create a sprite batcher, and this is going to draw everything to the screen. And we're going to need the graphics device so we can get access to the OpenGL context, and that's it. Okay, so I put in a bit more work since the last time. I did take a bit of a break, but if we look into our game, we can see we get a square drawing, which if we come to, I have decided to start putting all of my actual game stuff into the example game rather than putting it directly into game window. So all of our stuff that's required to happen in, or their default functionality, is still in here, and then we will still have all of our game specific stuff in the class of the game where the user specifies. So you can see here I create a sprite badge with the graphics device, and then when I draw I clear the screen, and then I can start the sprite batch, which right now does nothing. It just sets a flag, and then and if you haven't started, it just throws an invalid operation exception, because this will do other things in the future, but right now it does not. And then here we have draw rect, which takes into position, a size, and then a color, which we have white. So we'll draw a white square to the screen with a size of 100 pixels. And then we have we enter a sprite batch, and what this does, if you come here, it puts all of our vertex and index data into our buffers, and then we clear the lists to clear them off of the system memory, and then we set the current index to 0. And then usually this would draw. So if we come back to our game class, we then call draw, and because for a lot of rendering libraries, the sprite batch will draw when you do end, which does work, but what I want to do is make it so you need to call draw manually. So what this means is that you can reuse the same mesh data over multiple frames without needing to redraw the whole scene. I might add a method that does end and draw at the same time. I could also just do bool draw equals false, then if draw. I'll just do that. But then if you will be changing every single time, you can end this, and then you can put true into here, and so draw true, and then if we open the game, it should draw. There we go. So how this works, right now I only have the draw rect method, but all it does is, if you see here, we just check if it's started, then we check our origin mode, which right now I only have, if you look here, I have top, left, and center. So what this means is that it's going to draw based off the center of the screen, and then everything, and then all your all the rectangles drawn to the screen, they will be based off of the center position rather than the top left, which is, this is the default. So 0, 0 draws up here, and then we go 100 and moves this 100 this way, 100 this way. But then with center, 0, 0 is right here, and then instead of 100, moves it 50 this way, 50 this way, 50 up, 50 down. So right now we only have top left. So to achieve top left, since OpenGL is by default based on the center, your position would be going from the origin. So instead, what I do is we update our projection, which we do use orthographic since this is 2D. We just set the Y offset to be half of the screen height, so we can move it up half, and then for X offset, since we don't want to go this way, we want to go back, so we do half, which moves it back half the screen width. So then if we go up and then back, we are now at the top corner, and then we can apply all of our positions from here. So you can see here I have our X offset, and then I subtract from the Y offset. Because this is positive, this is negative. I think... No, I cannot do negative or Y offset. And then we get our indices, which is the current index. And then we increment for the next one, so on. And then we add, to the indices, we add 1, 2, 3, or 0, 1, 2, 2, 3, 0. Which that just makes, because we're using counterclockwise. I haven't actually made us do counterclockwise yet, so I'm actually gonna add this. Okay. We will do OpenGL color phase. Well, it's gonna be back face culling, and then we're gonna have our front face is gonna be our counterclockwise face. So if I did everything right and I open the game, we will still see a square. There we go. And then if I change this to clockwise, no, not that, CW, it should disappear. Oh, because I didn't turn on OpenGL.enable. We need to turn on color phase. Yeah, there you go. It's not disappear. So then if I do counterclockwise, I don't know why that's different, but we should appear. There we go. Then I also fixed frame buffer resizing. You can see here, now I call it OpenGL.viewport. When you don't do that, what happens is the viewport doesn't update, but the projection does, so it gets squashed. Now we can see, I don't know why the square changes like that. I would assume that the viewport changes, but the projection does not. So, you know, I'm pretty happy with this. I do need to change a few things so we can do textures with our sprite batcher. And then after that, I think that's all I really need to do for now. I could add circles, but I don't really feel like doing circles. So, it is what it is. But I could do circles. But yeah, so I'm just gonna add a bit more. I will add textures to the sprite batch, and then I'll add window and graphics device. And then the library is done for now with that. So I'll get working on that now. Alright, so we're here in the... I have gotten textures working on our sprite batch. So if we come to the sprite batch, you can see here is a breakpoint because I was debugging. So I have a private batch class in here, which just stores like each batch separately. And then this is just used to easily have them separate. These don't need to be public. I just had them public for, again, debugging because it wasn't working. But I just had the face direction wrong, so that was great. So this pretty much was everything that I was doing in just the sprite batch before, but it is put into a single class so that each like draw call can have its own, you know, like mini class in here, because I cannot do like colors and textures with only one draw call. So here I added the texture color elements, and then we have our shaders here for textures, which is fairly simple. The exact same before, but we pass in a UV and sample a texture. You multiply by the color instead of just returning the color. So I have also added a texture shader using these our new vertex and fragment shaders, and then we have, I don't need this anymore. I don't this either. Okay, so I have a dictionary and a queue. So this is the pool, and then this is the current ones that are in use. So every time I'll go down here. So every single time we request a texture batch, we'll want for a texture because all of the color go into the same batch. Okay, so they have a color batch, so they all go into this one batch. But then for textures, we cannot use one draw call for each texture. So what we do is we have a pool of batches. So here we do is we check if our dictionary, if we already have a batch for this texture, we just return the batch that exists. If we do not have one, which I do not need, it will complain. Okay, whatever. So if our batch does not exist, we check if the batch pool has any batches in it. If we do, we dequeue a batch, and then we add it to our dictionary. If we have no batches available in the batch pool, what we do instead is we create a new batch, then we add it to the dictionary. We do not add it to the batch pool because we would be taking it out of the batch pool if it did exist, so there's no point to add it. And then we can remember this later. And then I have changed this method to later I will have a camera, so I've just put prepare shader, and this prepares every single shader in general. And then I moved before when we were checking if everything was valid, I just moved it to check state or throw. We throw a new invalid operation exception if it is not started. I can add other things here later if I want, and that's the beauty of it, without needing to change every single method. But then we can see in our start method, before we were just changing if it was started or not, but now we check if it has started. We don't do this because now we have things that will mess up everything if we start it again while we're already drunk. So we can pass in a sampler, which if we do pass in a sampler, it will change the current sampler. So it's not null, we set it to the sampler value, and then we clear our textures dictionary and our batches dictionary, because if you come down here after we end, we call clear batches. So this clears our color batch and then all of our texture batches, so that our text data does not pile up. And then we on queue the batches into the batch pool. We don't clear the dictionary here because we use it when we draw. So when we draw, if we take the texture ID in the batch and we use that, we go into our textures array, we index with our texture ID, and then we get our texture. So if this texture does exist, we'll bind our texture. This was again for debugging, and then we have our batch, and then we just draw our batch on the screen, which is exactly what we were doing before. And then I also put unsafe here instead of being scoped to the whole method because I like it better. I don't like seeing unsafe too much, so. Okay, so now for something else, I changed orthographic, the orthographic off center, so I don't need to be doing all that offset nonsense anymore. So this makes it so the top position is 0, then the left position is 0, which this means the top left is 0, 0, and then the bottom right is, as you can see here, XY. So I don't need to be adding offsets to any of these things. Now here's where the texture comes in. So all we need to do is I'll show direct, it is simpler. So all we do is, instead of just accessing the vertice and index array from the class, we get it from the color batch instead, and So it's exactly the same, but we pretty much just append underscore color badge to everything. And then in .texture, this one is a little different because we need to provide our UVs, which are all correct. And then we also need to get our badge from the texture ID. So this is where this method comes into play. As before, if we don't have a batch for the texture ID inside of the batches, we check if we have one in the batch pool. If we do, we get one, we add it to the dictionary, otherwise we make a new one and we add it to the dictionary and then we return the batch. So we do the exact same thing with this new batch, providing UVs now, and then that is it. And then we try to add the texture we are drawing to our textures dictionary with the ID. And this makes it so if we've already added the texture, we will not try to add it again and then get an exception and then crash. So our draw method is a lot different now. We have prepare shader with our color shader. You draw the color batch, and then you have prepare shader for our texture shader, but we need more than just the model and view matrices for this. We also need to set our our texture index. Sorry about that. And then we apply our sampler when at drawing time and at start time, because that can be messed up if we apply another sampler before we call draw. We apply our sampler, and then we enumerate through each of our batches for our textures, and then if the texture does exist, so this should pretty much prevent any errors, okay, from safe coding. So if the texture exists, we bind the texture and then we draw the batch. And then I also added dispose to dispose with the color batch, and then we clear the batches to put all of our batches. We can put all of our batches into the batch pool, and then I did forget to clear the batches dictionary. So this is why I'm doing active narration, so you can see what I've done wrong as I'm doing it. Okay, so this is really it. So now we can see I have added a few things to the game window class actually. So I added a key up method. That's literally it. I've added a nice player position vector 2 here, which if the key if we have A down, we move it left 100 pixels every second, and if it's down, if these down, we move it to the right 100 pixels per second. That's all timesing delta time does, is normalize our movement. And then we can see here, when we're drawing, all I need to do is pass in a sprite batch draw texture, and then we pass in our tree texture, which I didn't say this, but to load our tree texture, all we have here is to do texture2d.file, and then we pass in our graphics device and then our file path, which this is based off of the executing directory. So if we open up from file, we just return a new texture2d graphics device, and then we read the file. And then in here, our texture unit, which is always 0, but I have that in case I want to change it. Graphics device, we get our texture, and then we set our data. We bind, and this is using SDB image, but in C#. I've used SDB image. It's a very good library. I would use it if you're in C++. If you're in C#, you use SDB image sharp instead. So we have our better data, and then this is what's new here. Okay, I have to set the width and the height for the sprite batch, because if we come here, you can see instead of passing in a size, we just pass in a texture, and then we change the positions based on the texture size instead of the rectangle size we provide. So I will add a method to do that later, probably. So now there is one thing I need to do, and that is actually improve the window itself. Because right now, what's happening is, you still see a bunch of silk.net stuff, which I want to make it so the user, or whoever's the programmer, does not need to touch silk.net, because if I ever change from silk.net, their code's gonna break too. So the idea is we're gonna make a bunch of my own enums, and so right now all I need to worry about is key and then iKeyboard. I just won't pass an iKeyboard, it's that simple. So we're just gonna have key and key code, but I'm also going to create an input class per window, which will hold all of the input, so that you can see here. This is of course getting into a game framework territory, but it's just everybody's going to be using this for games. Okay, it's really called a game window. So we have, because here you can see I am managing everything myself, and I want to move this to an input class. And then that's all I really need to do for now. It won't have frame buffer resize in the window, because if we come to graphics device, I did turn up blending to test something. But if we see, I only enable blending or not, we have frame buffer resized. Because you don't really need any of the other like events. If I find that you need other events, I will add other events. But I'm just gonna add a new key enum to use instead of silk.net. So I'm gonna get working on that, and then I'll be back once I'm done. Okay, it is I think about an hour later since I ended, or like an hour and a half later since I ended the last clip. But I have, as you can see here, the input method is different. Okay, so instead of managing it myself, Lumi2D now does that. So I also made it so the tree can go up and down, and just to display that it works. Here is our tree, and we can move it. Okay, so it works. And then you might also notice that this doesn't have a vector 2D anymore, instead it has a vector 2 double. So pretty much what I'm doing is I have completely made it so that the programmer does not need to use silk.net at all. Okay, the idea is to make it so that they will never use silk.net, but instead my own stuff. So you can see here I have added a keys enum, a mouse buttons enum, a keyboard and mouse class. And I've also added a vector 2D extensions, and this converts the silk.net vectors to my vectors. And then I moved the color extensions into the internal namespace just so that people cannot use it, because I don't want people working with vector 4s directly with colors. Anyway, we have I'm gonna go over what's outside of the input helper. So this just converts the silk.net key and mouse button to my enums. And then, so this just maps world 1 and world 2, because this is, you can see layout key 1. I assume that's what these are, but I might be completely wrong, and if I am, then that'll be an issue I can fix later. And then these are my vector classes. Very simple. They don't use SIMD, but I don't know how to do that, so oh well. I changed something in here. Oh yeah, everything that's exposed to the person who will be using the library, everything has been, oh my god, everything has been switched to use vector 2 ints. or vector, my vector 2s instead of fulfil.net. So I'm gonna come into game window, and I don't need this name. So you can see here I've added a keyboard and mouse fields and properties. And then if we come down, I have also renamed the methods a little bit. So load's now on load, update's now on update, and render is now on render. That's because I need to do certain things. I used to be doing things, but this lets me do things that will always happen instead of begging or hoping that the person who's using the library not override functionality I've added. So this actually just makes it so that it will always work no matter what. Well, it's ever my fault. Or yeah, so everything that happens in the library will need to happen unless they have like an exception or something. So I have added these two methods have always existed, but I've added 3 mouse ones, and then I've renamed load, well, onload for the virtual onload to called initialize. So I moved here. I want to be here. It does not close with escape default anymore. I removed that. I want to have as little default functionality with this library as possible. And it's really bad if you hard code it to always close the game if escape is pressed. But all I do is when a mouse button is pressed, I call the release. When it goes up, I call the release method, with the button, and then when it's down, I call press with the button. And when it's moved, I just set the position to the new mouse position. And then for keys, where are the keys? Here we have on key down, on key up, and this does the exact same thing but with the keyboard instead. So if we move into these, mouse and keyboard the exact same, except mouse uses mouse buttons and has the position and delta. I should not have scroll delta. I need to add that. We're gonna add a public vector to scroll delta, which will be a get internal set. Okay, and then we're going through this together, guys. Don't worry. Mouse dot scroll plus equals mouse on scroll. I'm going to name to on scroll mouse scroll wheel. You can see we have an X, Y, and this is the delta. I think. Is it? No. Okay. I mean, I need to also store a vector to int scroll position. This is instead just gonna get, and then we're gonna have a scroll position. Then a scroll delta. We're just gonna copy this and then change all these to say delta instead. These should all be initialized to 0. And then this gets scroll delta. Okay, so now when we into game window, I assume that's what that is, because if you look at scroll.x, it says the x position of the scroll wheel. So we'll do mouse scroll position. There we go. And why don't you like this? Load. Probably don't want to cast it to an int, but whatever. Okay, there we go. So now mouse is ready. So we have a position, delta, scroll position. Then we have a bunch of hash sets for release, pressed, and down and up buttons. Then we just have methods here to check if they exist in the hash sets. Then and then we call this after every render frame, after we render to clear the events for the press and release, because this is if it was down. If it started being down this frame, or it started being up this frame. So that's what these methods do. They just manage all of that. So when you press it, buttons are pressed. It gets added to buttons pressed and down, and then it gets removed from up and released. And then when you release it, it gets added to up and released, and then removed from the other two. Then, if we look over here at the keyboard, it's the exact same thing, but it uses keys instead, and doesn't have any positional things, because you shouldn't really care if the keyboard moves. And I don't think you can even check if the keyboard moves anyway, so it's good that you don't care about it. But yeah, that is literally everything for now. I will have the source code in the description for this project. So if for whatever reason you want to use Lumi 2D for your next game, feel free to use it. There's not very much to do with it. You can draw a rectangle and a texture, and you cannot resize the texture dynamically, but we will have a full-on video designated towards more advanced 2D rendering. This is where we're going to end the video. If you liked the video, then obviously hit the like button. If you really liked it, subscribe, and if you want to see more of this, make sure you turn notifications to all. That way you get notified, and if you're not going to watch the videos, don't subscribe. It actually hurts my channel instead of helping it, so only subscribe if you're going to watch the videos, okay? Same thing with notifications, but that is all for this episode, or this video, I guess. There might not be another episode. I know I've talked about another episode, but there might not be another episode, but I will try to make another episode. But that is it for this video. Goodbye, everyone.